All right, ladies and gentlemen, so what we're going to do is we're going to go through the formative that goes through percent yield. So percent yield is going to tell us how well we did the lab. Did we do a good job? Did we do a bad job? So what we're going to do is we are going to first remember what the formula for percent yield is. So I'm going to write it right here. So our percent yield, I'm going to use percent as the symbol. Our percent yield formula is the actual yield. So the actual yield divided by our theoretical yield. And then we're going to multiply that by 100 because it's a percent. And so our actual yield, let's remember what that is. That's what we actually made during the lab. We did a lab, and then we got this value, okay? Theoretical yield is what we're supposed to get. So when we do our stoichiometry problem, we determine that we're supposed to get this much, and then our actual yield says we only get this much. So now we have to figure out what percentage of our total we were supposed to get did we actually get. So if we take a look at this, it says, through stoichiometry calculations, aluminum hydroxide theoretically produces 11.6 grams of calcium hydroxide. Calcium chloride theoretically produces 13.5 grams of calcium hydroxide. If it actually made 12.3 grams of calcium hydroxide during this reaction, what was our percent yield? So, first thing we have to do, we're going to figure out what our theoretical yield is. So we know we reacted aluminum hydroxide and calcium chloride. So when those two things reacted, we make a product. Now, in a lab, when we're doing this, we usually make less, the least amount. So we either make 11.6 grams or we make 13.5 grams. If we're thinking about this in terms of labs or in terms of stoichiometry and limiting reactants, we always choose the one that's smaller because once we run out of aluminum hydroxide, there's no more of that reactant to react to make our new product. So this right here, our 11.6, is going to be our theoretical yield because that's all we can make. After that, that reactant's gone and we can't make any more. So now, if we're doing this, we're going to calculate our percent yield. I'm going to use the letters A for actual and T for theoretical times 100. So now if we plug in our values, our actual yield, what did we actually produce? So if it says if 12.3 grams of calcium hydroxide is actually produced, so that's what our actual yield is. So this is going to be our 12.3 divided by our theoretical yield, which is 11.6, because that was the least amount that we could make with our reactants, 11.6. And we're going to multiply this value times 100 to now calculate our percent yield. So our percent yield is going to be 12.3 divided by 11.6. And then we multiply by 100, and we should get 106%. Now, thinking about 106%, is that good or bad? I mean, yes, on a test or something like that, 106% is awesome. What about in a lab? Can we make more than 100%? No, we can't. So is this answer wrong? Did we do something wrong? The answer is not wrong, but we personally must have done something to cause an error. So we can be over 100%, which just means that there were errors. In the lab that caused that caused our percent error to be greater than 100. So that doesn't mean it's a bad lab. It just means it's not perfect. We didn't do a perfect job. We actually made more than we could have, which means that we made mistakes. So it's not a bad lab, but it's not a great lab, okay? The second problem says, in the following reaction of carbon monoxide and iron oxide, they produce iron and carbon dioxide. The stoichiometry calculations, iron oxide theoretically produces 31.4 grams of iron. Carbon monoxide theoretically produces 29.8 grams of iron. If 25.3 grams of iron were actually produced, what's the percent yield of this reaction? So again, we have to determine what is our theoretical yield. Is it going to be the 31.4 grams of iron or the 29.8 grams of iron? Again, remember that we have to think about limiting reactants and which one limits the amount of product we can make. And yes, you guys are right. The 29.8 grams of iron is our theoretical yield, because once we run out of that carbon monoxide, no more reaction can happen. So if we do our percent yield, we have our actual yield divided by our theoretical yield, and we multiply it by 100. Our actual yield, again, is the 25.3 grams of iron. And we divide it by the theoretical yield, which we decided was 29.8 grams of iron. And then we multiply that by 100. When we do 25.3 divided by 29.8, and we multiply it by 100, we get 85%. Now, is 85% good? All right, yeah. So 85% is good. So there were still errors. There were still errors in the lab, but this is a good lab because we were close to what we were supposed to be making. All right, so now if we think about percent yield and what is good and bad about percent yields. So I would say, in my opinion, if we have above about an 80% yield, we did a good job at this lab. That means that we got most of what we were supposed to get. If we go above 100, I would say if we go past 110, that means we're not doing great because we're coming up with way too much product. There's that little range where like you're doing good because you didn't get quite enough, but you're close, or you went a little bit over, but you're almost there. But then there's a huge range of error. So if we get like 14% yield, that means we didn't do a very good job. If we get 400% yield, we did a bad job as well. So thinking about those terms, like you want that close to 100% yield, which means that you did a really good job. Getting farther from that 100% yield just means that you're going to be doing a worse job. And that means, would you redo the lab then? Most likely you want to redo that lab to then do a better job in the future.